Celso Batalha here. Few students asking me, in fact, a couple of students asking me to go over the lunar phase simulator, and I would like to spend some time now going through that with you. So what you do a search on NAAP, astronomy modules or astronomy exercise. Even if you write wrong, you get it there. And then you find the lunar phase simulator, and then you activate it. Okay. Now, just a second that I need to. There. Can we all see this? Now you can see my window, right?
Yeah.
Okay. So the lunar phase simulator, it displays the sunlight. So the sun is somewhere to the left, and you have the moon orbiting Earth, and you have Earth in the middle. So the orbit appears to be a circle. So by now you know it's not. And at the same time, the moon orbits Earth, and in this application, it assumes that we are standing on a northward vantage point. So we are in the north looking down on the motion of moon or orbital motion of moon around Earth. And also Earth go around the sun and rotates on its axis of rotation like this. So Earth rotation on its axis of rotation gives rise to day and night. So day and night is not because the sun rises and is because the sun rises and sets, but not because the sun has independent motion or the sun goes around Earth. Earth is the one rotating the space, like I'm indicating here. So looking in the little window in the right hand side down, if you look in that little window, see the little person? The little person is on the top of the figure. This is the equator. So basically this haze, this kind of a whitish light, represents the equator. So this little person is in the equator now at sunrise. So as Earth rotates, now it's night and morning hours are coming, and that person sees the sun rising in the eastern sky right there. And then 6 hours later, noontime, the sun is up in the sky, as you can see right there. And 6 hours later, the sun is setting in the western sky, and you can see that as well. In another 6 hours, more or less, you are midnight. The sun is pretty much all the way below Earth on the position this little person is located. So basically, what this software allows you to think of is Earth rotation as one independent motion it has, and because of that, and because the sun is it's not stationary, but is nearly stationary in a point in the space, we have this impression of days and night as if the sun were moving, but it's not. The sun moves us. It also gives the ability of putting time. See that? So sunset, midnight, sunrise, noon, so on, so on, so on. Okay. So if you start animation, so in all this time that I was running this exercise, the moon is not moving. But in reality, the moon does move. Every day, the moon goes about 13 degrees in its orbit around Earth. So the orbit is not exactly a circle, but you might think of it as a circle, just to make it simple. And a circle has 360 degrees. Since the moon orbits the sidereal orbital motion 27.3 degrees, so you could think, okay, 27, 30 degrees, or 30 days, 360 degrees in 30 days. So you might think the moon goes in its orbit about 12, 13 degrees forward every day. So if you start animation, see, take for instance the sunrise as a point of reference. Sunrise and another sunrise, this is one day. So basically each day the moon goes forward about 12 degrees. We can show angle, I think. See that? So about every day the moon goes forward 12, 13 degrees, and as it does, the phase changes. Okay. So why does the phase change? Well, at every single position in its orbit, the moon is always half lit by the sun. Same thing as Earth. Earth is always half lit by the sun. Both Earth and moon don't have proper light. So the amount of that half-lit hemisphere I seen by somebody on Earth is what gives the different lunar phases. For instance, right now, somebody able to look at the moon would see only that little tiny, let me stop animation, pause. So in this phase, which is a waning crescent phase, so somebody, this little person right here, if it's looked towards the moon, is going to see only this lit hemisphere visible, because see, part of its view is in the dark, part of its view is in the bright. And in fact, if you continue, if you trace this line across the moon, you can differentiate and can separate the part of the moon that is bright, the part of the moon that is not. So when the moon is pretty much here, we call that phase new moon. Why? Well, because first of all, there is not a single reflected light ray coming towards Earth. See, it's pretty much being reflected in all directions except towards Earth. So that's one reason. The second reason we don't see the new moon is right in the same region of the sky where the new moon is located. The sun is there too, somewhere very close. And as a result, the sky is bright. You don't see it. You can't see it. So you could not see at all because there are no reflected light towards Earth, first of all. Second, the sun is in the sky. It's right on your view, so you can't see it. Now, why a full moon? Not because the moon is completely lit, but because half of the hemisphere that is being reflecting sunlight now is visible to Earth. And somebody on Earth that happened to be between sunset and sunrise, that person can look towards the proper region where the moon is and see it as a full moon. Okay. Now, if you look at this diagram here, at sunrise position, the moon is pretty much on the western sky, is a full moon, and the sun is rising in the eastern sky. So that's what you have exactly here. So you look towards east in the direction Earth rotates towards, and then you see a sunrise. And then you look back towards west, and then you see a moon, in this case full moon, setting. Okay. So these are basic features in this lunar phase simulator. It helps a lot to better understand phases and why they change. For instance, in the exercise that I'm giving to you guys, you are supposed to go to Stellarium and find the moon is September 6 at 8 p.m. September 6 at 8 p.m. So at 8 p.m., you have to find out which phase the moon is. And if you look in there, the moon is pretty much in here, in this phase. So if you look in the animation, isn't that correct, Amanda? Wasn't that the moon phase? So it's a waxing crescent phase, right? So the moon in the space happened to be right here. Now, at what time of the day can you see the moon? Well, you can pretty much see any time from here to there, but so when you get to this position, the sun sets and the moon is still in the sky. Look at that. You still can see some of the moon, right? Yeah. But eventually the moon is going to be set. So I ask you at 8 p.m. So 8 p.m. is somewhere in here, right? 7, 8. Well, the times are not the same. This is a simulation giving a circle. In reality, it's not a circle, it's an ellipse, kind of almost a circle. So my 8 p.m. doesn't show the moon at all, but the moon is in the sky somewhere in there. But certainly 3 hours later, which I ask you to check, the moon's down. You can't see the moon. Right? Now, let's say you have the moon right here. And where is the moon located 1 day later? So let's say this is your time of observation. Let's run the animation 1 day later. There. Oh, okay, a little bit behind. So 1 day later, the moon moved forward in its orbit, right? And the moon I see in the sky, so if you go back to the original position, the moon I see in the sky is going to be a little bit more to the east, right? If you observe 1 day later. And so all these details, you can go to Stellarium, confirm as being somebody on Earth doing the exercise and taking notes and everything. And then you can also use this simulation to check your answers, right? No mistake. And if you have any question, you ask me. All right? Okay. Keep sending me requests.
Okay.
Let me stop taking.